I am going to explain the anatomy of an ovule. For this, you have to go through the section of an ovary. So this is the section of an ovary, and in this section, few structures are very clear. Number one, the origin of the ovule. The area of an ovary from where the ovules develop is known as the placenta. So here, this entire line is the placenta. Placenta develops a stalk which is known as the funicle. Here, this is the funicle. The funicle gives rise to the ovule. The anatomy of the ovule shows that it is protected by a bilayered membrane. These membranes are the integuments. As the ovules are covered by integuments, the ovule is known as the integumented megasporangium. So what are the integuments in this diagram? In this diagram, this is the outer integument and this is the inner integument. These integuments never meet at the tip and they leave a small opening, and that opening is known as the micropyle. So this is the micropyle. This structure connects the ovule with the placenta. This structure is known as the funicle. This portion is the connection point between the body and the funicle. This point is known as the hilum. Such an ovule where micropyle is directed towards the funicle is known as the anatropous ovule. There are different kinds of ovules. Number one is the orthotropous ovule. Second is the hemitropous ovule. Third one is the anatropous ovule. Fourth one is the sarcinotropous ovule. Can you tell me what is the peculiarity you have observed in these four diagrams? See, number one is the orthotropous ovule. Here the micropyle is on the opposite side of the funicle. In hemitropous ovule, the micropyle is located at 90-degree angle with the funicle. The sarcinotropous ovule is that ovule where the micropyle is located towards the other end of the funicle. So what is the difference between the first type and the last type? So if you observe carefully, there is a rotation of the ovule. To explain these rotations, first we have to remove these diagrams. Now the rotation of the ovule. To explain the rotation, first of all we have to take a pencil diagram. So this is a pencil diagram or pencil sketch of the ovule. This is orthotropous ovule. Here the funicle and the micropyle are arranged at the opposite ends. Now this ovule, it rotates and finally it forms the hemitropous ovule. So this is the hemitropous ovule. Here the angle between the micropyle and the funicle is 90-degree. The hemitropous ovule now rotates 90-degree and form the anatropous ovule. This is the anatropous ovule. Now the anatropous ovule undergoes another rotation and forms the intermediate step between the sarcinate and the anatropous ovule. This intermediate step undergoes further rotation, forming the sarcinotropous ovule. In this way, these four types of ovules are formed. This is the rotation of the ovule.